session number 50, and it's quality craftsmanship in electrical installation. If you could please take one of the clipboards and make sure you sign in, and if you're from outside of Utah and you need CEU credits, please come up after the session and we'll get one of these sheets filled out for you. So I see a lot of familiar faces in the audience today. Sam and Kent have a lot of great info that they want to present to you. We're probably going to take a majority of the questions at the end of the session, but if you have any burning comments that you just can't keep to yourself, except for you, JT, please feel free to comment. So your presenters today, Sam Gines became an electrical apprentice in 1999. And Sam served in the United States Air Force from 2002 to 2008, so thank you for your service. Sam became a journeyman electrician in 2008, and he's currently working on his electrical engineering degree at Utah State?
Slick right now.
Okay. Working on the electrical engineering degree. He's installed all types of ATMS systems throughout Wyoming and Utah. And at the TOC, he started in 2012, and he's working on maintenance of the traffic management system, variable speed limits project, inspections, project plan reviews, and also assists on the express lanes program maintenance. And Kent Thurston is your other presenter. Kent became an electrical apprentice in 2005 and has worked on all types of ATMS systems throughout Utah. He started working for the TOC also in 2012 and assists with the traffic management system in VSL, inspections, project plan reviews, and manages the express lanes electronic component maintenance. So take it away, guys, and I'll pass these around in the back.
Welcome. Yeah. A lot of this that we're bringing up is just things that we see in the field, you know, as we come up to do inspection, not inspections, but field testing. This is just to help everybody else kind of see kind of some of the stuff that we're missing.
So the purpose is to show items that are being missed during inspection that we find after the project has walked away. These items that we are showing cost the taxpayers and UDOT money to fix later, if not caught by the inspector. If it's caught by the inspector, we can usually get the project to do it and the contractors. Disclaimer, we're not calling out any projects or contractors. This is for info of what we see in the field. This is to help inspectors see things that they might not see when they are there looking at the project. What are the NEC and the NESC? The National Electrical Code and the National Electrical Safety Code. What are the differences? The NEC is to safeguard persons and property from electrical hazards. The NESC to safeguard persons during install, operation, and or maintenance of the electrical equipment. What training did you receive to inspect? Should you have an understanding of UDOT standards that deal with the electrical? Should you have an understanding of the NEC? These are just questions. What training should be provided to the electrical inspectors? This is some ideas that we think would be helpful. Maybe a yearly ATMS training for specs for the people doing inspections, just, you know, updates, it keeps on everything. Also, an NEC refresher course. We are here to help.
Here are a few things that we've seen in the field that do not meet spec. And another disclaimer, we're not calling out any projects, contractors, inspectors. We're just helping inspectors catch another eye of a different view. And these examples that we're going to show, they relate to safety and they cost money to fix. So you're looking at a meter base, but minus the pipe that's laying there, what do you see that's missing? It's missing the pull box. You know. What's that? But the pull box, you're missing because, you know, a greatest concern is that we have it in our spec to put that pull box outside the meter base, so you're not pulling into a live panel. So if you're at a traffic signal, you gotta tie into that meter base, would you rather pull into a pull box or into a live panel? You just can't shut down a signal that easily. I mean, y'all know when a signal goes into flash, how long it takes traffic to back up. Doesn't take long. So it's the same aspect as far as the safety wise. It's that 5-foot push between the pole box and the meter is easy compared to pulling 300 feet or more into the meter base. The other thing that we're seeing is that the two ground rods. The first one's in this pole box. The first one's in the meter. The second one's in the pole box. But what is the minimum spacing between ground rods? 6 feet. We don't get that sometimes in those pole boxes are so close to that meter base. So you're just canceling out your second ground rod. You're making one system.
Meter bases. Ground rods. What's the difference between a supplementary and auxiliary ground rod? Supplementary is a ground rod that is required. Auxiliary is not required by the code, but UDOT standards. So the ones in the junction boxes at every location in the junction box. They are required to be a minimum of 6 feet apart, as we've discussed, and grounding electrode conductors needs to be continuous from one rod to the second rod to the ground bar in the meter base. So they cannot be split. It needs to be a continuous run. That also has to do with safety for surges and other things.
So here's a few more things that are being missed. This is for a NID install for the speed wavetronics on the side of the interstates. The CGBs, they're just putting grommets up. They're not protecting that with that CGB to help relieve that pressure off of the cable. We're also missing the drip loops. See, here's a prime example. And we're missing the drip loops at the bottom of the boxes too. And they're not like a traffic signal. I mean, traffic signal runs them through just like this here. We're not on a NID on the ATMS side, we're not running them that way. And here's that. It's not a great example of a drip loop, but it's the only one I have a picture of. So here we're looking at an RWIS, the Roadway Weather Information System site, and you can see that the conduits come up inside. Here's the right out of the specs, the standard drawings. Does anybody see it? The conduits don't match as what is given in the spec. They come inside the frame. There's a question for you. Should have been accepted. Why? The overall appearance is going to be how you're going to fix that, how you're going to get that box. How are you going to get the conduits to that box that you're going to have to mount? The big one is just, it does not meet spec. So here's another example of an RWIS. The conduits are too shallow. They're only inside the
collar.
sorry, the collar of the pad. What's the requirements for entering a pull box? It's at least 3 inches from the bottom. So yeah, they're at least 3 inches, but at the same time, they're too high. Now your pull box lid can fall in there and crush your wires. So with fiber optics, it doesn't take much to damage that wire. Do you guys see anything?
Yeah.
So they did pour it down deep, but when they put their frame on top of their base, now their conduits hit their frame. So their fix was run the conduits back on top of the gravel. But if you go back to that drawing that I showed you a couple slides ago, they just still didn't match what the drawing showed. Do you guys see anything else?
How about supports for the conduits coming up? That looks like just tie wire.
How about grounding? The ground wires are just wrapped around the structure. The conduit supports. It's the crazy thing is this is in the spec. It gives you the whole template to set up the entire structure. It's right in the spec. So it's hard to see how you could really mess it up. And you're driving up to this site, you know that from the plans, this is an RWIS site, but you want to look around and take some more notes. What are a few more items that you can see that would be a later issue? What's that? The pull box is definitely one. There's no support on the H-frame for the disconnect. My arrow's off. But there's supposed to be another support right in here for your disconnect.
Supposed to have two means of support for disconnects.
But inside your pull box, what do you see that's missing? Ground rods. The floor. Bushings.
Conduit bushings.
The conduits are too long. And the biggest thing is just it wasn't finished. I mean, just, there should be a collar get put around it. So it's just small things just to look for. Even though it wasn't finished, it's small things that you can look for ahead of time. The next one, you're looking at the standard drawings for a breakaway system. Anybody tell me what a breakaway is for?
Yeah.
So your breakaway systems go inside your clear zone. They're also outside your clear zone, but when they're mounted that way, they still should be, when you mount your pole, it still should be a breakaway system. You're putting a breakaway system in for a reason.
Put a breakaway, it needs to be an operational breakaway system.
So the biggest thing we're seeing, that I'm seeing, is a lot of these foundations are too tall. I'm pretty sure, I believe this one is outside of the clear zone, but it's probably an example of it's 12 to 14 inches too high. And you're supposed to have, within 5 feet of this
5 feet.
base, a 60-inch level spot that's no taller than 4 inches. Now, why would you want that? What's the
Max.
biggest reason? So when your car hits
So
your
the car-
breakaway, it doesn't destroy the undercarriage, that, unless you're driving a rice rocket or something. But that's your biggest thing. It's not to stop the car suddenly. It's to allow it to break through and go down. Plus, it doesn't damage your anchor bolts, so you don't have to. You can just go put a pullback up and be done. The other thing I noticed is torque settings. Anybody know them? Close.
80 and then to 70.
Torque it to 80, and then you break it loose and you retorque it to 70. So that it strains the bolts and then it loosens them up enough so that they break away when the car hits them. And it took me forever to find where the torque settings are, but it is on SL12 in the standard drawings. Here's another prime example of,
So when this was first installed, you couldn't reach the batteries. If you stood directly underneath it, the battery box, everything was above your head. That's how high it was.
it's a breakaway system. Here's the fix. Now now you're gonna go airborne.
If you
So
even
we got
go
some
above
Fast and
it.
Furious going on here. Here's the side view. Yes, it is easier to work on the battery boxes now, but that's beside the point on this one. So you see there's 28.36 feet from the traveled lane of a 70-mile-an-hour interstate. If you look here, 70 miles is 30 feet. 2 feet away from here, this foundation technically safe, other than it's not doing what its purpose is as a breakaway. So it's inside the clear zone. It should be ripped out and taken down. And, sorry, lowered, not taken out.
Should be to the spec.
Yes. So,
It's weird
another
angles.
breakaway system. Anybody see some issues? Besides the guy in the shoes. Okay, besides all that, what do you guys see? It's another breakaway system.
That is rigid conduit
There's
behind
rigid
it.
conduit. Therefore, if that sign gets hit, it's stopping, it's not going anywhere. And besides the conduit, you have the pull box that's not got that 5-foot clearance. They fixed the conduits, left the pull box. But this site has been fixed. The pull box is
Pull
now
box and everything.
back there by the grass and has that 5-foot swing radius.
So this is one that was caught during the project that they fixed. This is the example, you know. This is perfect, how we want them to work, how UDOT, how we want them to work. You know, that's what we do all this for.
I wasn't able to get back out and get the corrected picture. Kent tried the other morning when he was out working and he stopped at the wrong sign, but no. But
Hey, it was early.
it was early. Here's another breakaway system. You can see it's 7.5 inches above the ground. That's not that 4 inches that we're requiring.
And that's state furnished. This is the actual breakaway plate that goes on. We're giving them stuff that's 7 inches to the top of that, and we're requiring it 4 inches. Is that gonna work? We're setting them up to fail there,
It's something to think about.
and they're supposed to be.
In this case, they were missed. So you're looking at HOV cabinet,
Hard to tell from the
but
picture.
it's really hard to see, but can anybody pick out something really?
Yeah,
Thomas got it. It's too deep in a hole. It's a, pretty much, it's below grade. Look, Kent, we got us a watering hole.
yeah. And in the
Hey.
winter, the snow melts, and when it gets cold, it does ice over there. So when we go to work at that one, we have to be extremely careful just because of slip hazards.
You know, and you see back here, you got disconnects, you got transformers, 480 volt, and now you're standing in 2 feet of water, or a foot of water.
That's when you hope for good grounding, right?
You hope for something. It might be hard to see.
I don't know, I heard everybody giggle.
Does anybody see the electrical tape? Electrical tape fades after and peels off. Pretty short time frame,
Yeah, it might be Super 88.
but it's not approved support. Anybody see anything else? Not so much rigid.
Could be if it's,
You do have a point. Your rigid is too tall. It's too high. If a car hits it, you're gonna damage your conduit, and now you gotta dig to fix your conduit as far as the breakaway system. But your signpost, in this case, is 2.5 inches. It's hard by the picture, but I'm looking at 4 to 5 inches there. By the other spec, it's good. By the spec of a round pole, it's just too tall. You're looking at some H-frame disconnects. There's some things that we've been seeing, a lot to do with like the neutrals. This one is just a butt spliced and a little bit of tape around it. So for the little bit of tape that they got around it, is that really insulated? You don't want your neutrals contacting your anything. It's isolated for a reason. It's your neutrals.
it looks like a pretty sharp angle on that splice too.
So your disconnects, they don't come with the neutral kit, but you can get a neutral kit. Neutral kit allows you to connect two neutrals without breaking it through the disconnect. Here's a prime example of that not being insulated. The neutral is just butt spliced and just put in there. It's completely uninsulated. Anybody see anything else? No, they're not at this point, other than the butt splice. Your number 6, or actually I think in this case it's number 8, white, is phase tape. By code, it has to be continuous throughout the entire run. The green ground wire that you cannot see in that is also the same thing. It must be continuous throughout the run of the wires. There's also one other thing that's probably really hard to see, is that the ground wire lands on, there's 2 ground wires landing on one lug. It's not listed for 2 wires. And one thing, this is just, it's not on this note, all these little holes in the back of the disconnects, if we throw silicone on those, it helps keep the water out,
And the
keeps
wasps.
bees out. Nothing's funner than open up a, nice word, nice funner. Yeah, a bee's nest looking at you, ready to attack when you open up a disconnect. I guess I wrote it all out for you, I didn't have to say it. Here's another disconnect. It's more cosmetic than it is, yeah, functional. The conduits aren't level. That's a quick fix. A level. Here's another, use a neutral kit. It might not be required, but it does have a place to mount it, right there. And then the other thing to look at, is the conduits. There should be if they use, I'm gonna mess up these words, concentric knockouts, and there's another it's, one knockout is built in. So it's whatever's supplied with the can. The other knockout is one you make with your own KO. One of them requires a bond bushing, the other one does not. So the one that you cut your own hole does not require it because you're breaking that fresh metal, you're cutting the paint. So here, it's a hard question. Did they cut it out? Or did they just use the manufacturing holes? In my eyes, I would have put a bond bushing in just to eliminate that. That way your conduits going down are protected. And then once again, your neutral kit. Does anybody see it on this one?
This is the bottom of a disconnect. So this is the ground level.
Supports one. Is HDPE conduit supposed to be above ground? UDOT spec is rigid conduit or flex is allowed to be above ground. And then, should there be a pull box? The power source is over 300 feet away. There's another reason for the pull box. It'll be another slide. But yes, a pull box, it would help with those poles. So here's the same disconnect, just the picture of the disconnect. You guys see a bunch of it's a coupling, a compression, fitting, a reducing bushing,
So it goes from,
Myers. Is that 5 different parts there just to get that 2-inch into a 1-inch hole? If that pull box was there, you bring the 2-inch into the pull box, you run a 1-inch out of the pull box up to your disconnect. There's also no bond bushing at this point. And it's reduced from 1 to 2. Reduced to 1 from 2.
Is that fiber going through that power box?
No. And your wires, once again, are not continuous in color. breaking the neutral. Transformers, sorry, not transformers, generators and emergency backups are the only place I think you can legally break a neutral. This isn't powering a generator. It's just to throw it in there. This is the backside of the disconnect. Where they reduced it, I guess it's really hard to see. Where they reduced it down to the 1 inch, you just got a place for water to sit. So when this sign, if it's for avalanche control, is gonna have snow on it, when that snow melts, it's gonna sit in top of that conduit and run inside it. A water trap. The beacons, they don't have the right hardware. They're installed with lock rings, a 1 inch conduit with a inch and a half coupling that holds the beacon. I came from Wyoming, the wind blows, the signs move, or beacons move. That's the big thing. The beacons, they're not secure. There's no set screws in your hardware. So therefore it's gonna spin those heads. You're looking at a meter panel. Does anybody see anything missing? You're missing a label. I mean, how many of you guys have been out troubleshooting power and go to 5 different disconnects that are different panels trying to figure out which one goes to what? How many traffic signals get turned off on accident because they went to the wrong one? How many HOV systems get shut down because you went to the wrong breaker? Labels, it is important.
And accurately, as
Yes.
he was stating.
It is in the spec and it is in code. The permanent Sharpie, yeah, it'll hold for a few years. Eventually it'll fade.
But even that's hard to say, H-frame load center. What H-frame load center? You know?
At this point, there's 2 of them. There's one right next to the service point, there's one across the street. Sorry, I want to make sure I know what I'm looking at before you guys do. This one's awesome labels. They labeled it. But did they label the second one? So, no, there's no gap in between the rivets. HOV runs off a 240 from this point to the H-frame. So it's missing a wire tie or cable tie or a breaker tie. But before we get to that point, does anybody see it?
That guy right there.
There's an arrow here somewhere.
Oh.
When they mounted their label, they took the drill bit and drilled it through and smacked that lug.
Live.
So they arced their drill. It's probably, yeah. He's probably feeling really good after this one. But you know, if you're gonna put a label on, please make sure you're not gonna smack the live parts behind it.
The breaker.
But when I said the wire ties, this is a 240 system.
Breaker tie.
Sorry, wire tie, breaker tie, a tie. There's supposed to be a wire, a cable, something that goes between the 2 breakers to allow that not to. So one trips, it'll trip the other.
Because there's only just one neutral to it, so.
And the biggest safety is you shut off one, you're still working and you pull that neutral, you have a potential of getting shocked from that second circuit still live. So if you shut down one where it's tied together, you need to shut down the second one. So I actually got this engineer flow chart yesterday. Before I already had it in my presentation, I got it as a Facebook notified. I was like, I already using it. So there you go, just a little laugh. It works, just don't touch it. Here's another one. Don't touch it. So here, the next slide is, it's a lighting pole. It has some flex running from the wall down into the pole box. The flex code says it's not
Rated.
rated for direct burial. Here's just another angle. But in this one, the conduit joint right there, just about halfway up, the glue is not glued very well. You can actually get movement in that joint.
How about the depth on the conduit?
It was at least 8 inches, if that buried. No, it's all 2-inch. So by NEC, they're supposed to be at least 18 inches deep. By UDOT standards, they should have been over 5 feet deep. Oops, I missed us. Go back. I messed up the whole slideshow. Way to go. All right, well, the picture before it shows the lighting pole. The anchor bolts are actually beat in, because they used the wrong template to put the light pole down on top of the anchor bolts. And here, it was an awesome video that was supposed to play.
Last minute messing.
Hey, oh, yeah. So here's the other side. Here's that flex coming into the ground again, just to show you that they actually really did bury it.
And it's
Here's-
type EF.
It's not rated for it. Is this right? Not even to NEC. I don't know if it's easy to see. That's an awesome ground rod.
What specs say on ground rods? 10-foot what? 3/4.
3/4, 10 foot. Does this look right? It measured out to be 28.5 inches long. And it's visibly shows a cut. So they got a 2-for-1 deal. They got a couple ground rods out of one. But that was easily just pulled out of the ground. Also, in the pull box, I don't know if you can see it from your guys' angle. Do you guys see anything in the pull box? It's a rat's
Dirty
nest.
picture.
It's not neatly coiled. Anybody see anything else? Bushings.
Bushings.
I heard bushings. It's missing the bushings on your conduits. And the orange ball is supposed to be red. So he's using communication marker for power. Here's a, right out of the NEC handbook, shows you 3 ways to drive a ground rod. If you can't drive it straight down, try a 45. If you can't get 45, get an inspector to watch you throw it in the ditch in a 30-inch ditch. Those are all approved. Yes, it is a breakaway.
It's a lean-to.
It's not level. Don't know why, but the sign's level. So I'm unsure what happened. It's just not level. Everybody loves the flex, especially Mike. But what does the NEC say about flex? Not subject to damage. Anybody see anything else with this one? Breakaway's too high. What's that? I prefer to see like Schedule 80, the conduit's actually poured inside the foundation with a plastic piece that breaks that has that point of break. And then
We're actually
original-
trying to get that added into spec, a breakaway system.
we don't have
Yes.
one. That's the best way to say it. We do not have a breakaway system spec,
We're working on it.
but we are definitely working on it.
The ETC stuff has some that have been implemented into it, so we're trying to push it other places.
But if that conduit comes up next to the foundation, in the foundation, it has that breakaway point. It keeps it clean. It gets rid of the flex.
Yeah, if it comes up in the foundation, and then it comes up inside the mold, which is typically how they happen. But some of those electrical installations we've been putting on are coming up next to round poles, or as you show there, the I-beam.
Yeah, this one's an
Yeah.
I-beam.
And then there is, the contractors kind of left to their own imagination how to connect that, and then how to connect the beacons on top. That's all really, as you say, non-existent
Yeah.
or super vague.
Those are the specs.
Parts make it work.
Those are the specs we are working on.
We can talk later at that, and I can show you some stuff that we've done with the ETC system breakaways, if you'd like to see that.
Anything? How do you trace a wire? Oh, they're gonna start jerking and making a bigger mess. That's just it. It's a rat nest. Yeah. What's that?
The ground bus that's attached to the box, they're not wet location rated.
Nice. There you go.
They will rust and rot away, guaranteed.
That's a good point. This one's, it's got, you know, goes back to that no conduits coming out of the foundation. There's not a set way to get power through a breakaway system, through a foundation on an I-beam, like you're saying. But the other main concern, it's a breakaway system. Look at that foundation. Both of the foundations are outside, you know, they're up and out of the breakaway point.
Above ground level.
And then pour the conduits in the foundation. This one,
There's multiple things in here. There's proof that UDOT guys actually do use their shovels there.
we do work. So, we got a notification that the HOV system went down. No power. So we drive down there, we find this delineator is hot at 480 volts.
As in voltage is on it, it didn't trip the breaker.
So, for one, somebody can get really hurt by driving that ground or that delineator post. Second, why didn't the breaker trip? That's an ongoing issue to try to figure that one out. You know, big thing, you know, that conduit, 14 inches deep. That I cannot answer.
But they missed the fiber, and that's important.
Barely. They barely missed the fiber. So, the minimum your
UDOT's
minimum cover
minimum.
for your conduits under a sidewalk is, and paved surfaces is 3 foot. Greater than 20 feet away from the edge of the pavement is 3 foot. Within 5 feet of the edge of pavement,
Within 20 feet of
Sorry.
the edge of pavement is 5 feet.
it's way within 20 feet. So if they didn't call in locates, they were expecting that conduit to be deeper. The one out of the 3 is the wrong connector. It's either missing the bushing to keep it watertight, or they just ran out and they just found what they could, put it in to connect the flex. Yes, that's
Yes.
through the top. And this is a solar cabinet. We have multiple wires in the home X. Not sure why they even use the home X. There's places to land those wires on a bus bar already here. There's a whole bus bar. So we're not sure. The wire in the top picture over there is black wire phased red, landed. These wire nuts were used, they switched the polarity from hot to negative because they ran out of wire.
It wasn't because they ran out of wires, because they mixed it up at the solar panel.
Okay.
And then they hooked it up wrong and had to redo it.
So there you go, there's the real explanation.
Wire, they just cut it and redid it. Yeah.
I don't know about you, but that's kind of scary when you expect a DC and it's positive. Or, sorry, when you expect a negative and it's positive. Black wire in, red wire out, or vice versa. And this picture also shows the wires not being continuous in color. Number 6 and smaller should be continuous in color.
By ensuring that we embrace craftsmanship, we are saving taxpayers' dollars to enhance, and it also enhances safety for everyone. UDOT is currently working on standards and specs. If you are out inspecting a project and running into any electrical questions, call us. We'd rather come out and help you solve the issue than fix it later, or we will get you to the right person for the questions.
Anybody have any
There's the
questions?
information.